Good morning, Shweta. Today we are going to enter into our fifth unit, which is called numerical methods. Now, in this unit, you are going to learn about three concepts. One is the finite differences. Okay. Then we will be using our two techniques. One is the Newton's forward or backward interpolation formula, and then Lagrange's interpolation formula. The main concepts behind these three topics, that is mainly in our business concepts. How we are going to handle the given data, how are we going to interpolate our demand, our supply, our equilibrium conditions, etc. Okay, so we are going to see what are all the important formulas to be used here. First and foremost, we are going to see what is this forward difference operator. Forward difference, that means as and when we move forward, we have the formula as delta y naught is equal to y1 minus y naught. That is the second value minus the first value. The first value is taken as y naught. Similarly, delta y1 will be equal to y2 minus y1. Delta y2 will be equal to y3 minus y2. So, in general, our delta, that is the triangle symbol, and followed by y1 is equal to yn plus 1 minus yn. Okay. Now, the difference when it is in the function, then it is the delta f of x is equal to f of x plus h minus f of x. Even this is an important formula which we have to know. Now, what are the properties of our operator? Now, if the c is constant, then the forward difference operator into constant will give you 0. Okay, you just write the properties. You need not write the proofs in the classwork notebook. Okay, now we are going to see the distributive property. What it is, we know the distribution means you have to split the terms. So, I put delta of f of x plus g of x. So, it is split into delta f of x plus delta g of x. This is the next property. Now, coming to the third property. Now, if c is a constant and you are having delta c into f of x, that means I can take the constant outside the delta, because delta c will become 0 according to our property 1. So so c I am taking it outside. So c into delta f of x. And then we have other properties also without the proofs. This is delta m power n into delta n power n will give me delta m power n plus n. And again, if I have delta f of x into g of x, then we will use like our differentiation formula. That is, when you are finding the differentiation of two terms which are in product, that is d of uv, d by dx of uv, then u into v dash of x plus v into u dash of x. Similarly, we will have that. And again, when it is in division, you have to remember this formula. As of now, we will be having only simple substitutions on this formula. Okay. Now, we are going to see how we are going to construct the forward difference table. That is, you will be given a table for the values x and y. Okay. Now, you have to find the differences or you are going the finding the differences in the forward direction. Now, you write down all the x values, write down all the y values. Now, you should be careful that you should leave enough space between each values of x and y, because you are going to write these terms in the middle. Middle in the sense, it should be in the middle of x, y and y1, then y1 and y2 similarly. Okay, so it should be in between. So we have to be very careful, that is, we are going to leave enough space. We are not going to write it very closely. Now I write all the x values, then I write all the y values. Then what will happen? I am going to find delta y naught, that is y1 minus y naught. y1 minus y0, I'll write it here. Between y1 and y0, I'll write it. Then y2 minus y1, I'll write it here. Then this minus this, I can write it here. Then this is y3 minus y2, I can write it here. Then y4 minus y3, I'll write it here. So these are all deltas. This is the first delta I am obtaining. Now when I am going to find the next difference again the differences of the difference, so that will become delta squared. So this minus this I can get here. This minus this I'll put it here. This minus this I'll here, and this minus this here. Then again I can go to the third one. This minus this I'll put it here. Again I'll be going on till I reach one position or one point where I'll be having only one value. I cannot find any more differences. I have to stop till this place. Okay, I have to stop till this place. That is, I'll be finding the same way the differences, and I'm going to find it here. Now I'm going to stop there. Now this, if I take all the values in this direction, that is from the slanting slope from the left to right, then it will become my forward difference table. Now if I want it in the backward, you will be learning now in the same unit what will be the backward difference. Then I can take this section, that is when I start from my left bottom to the right top. So it will become my backward difference. We will see how we are going to calculate that also in this lesson. Now, what is this backward difference operator? That is, it is nothing but you have to tilt the triangle. Okay, you tilt the triangle and then you can say y1 minus y0. y1 minus y0. Okay, we are not going to bother about the thing, but we are just bothered about only the symbol as of now. The subtraction is as such, but we will be using this symbol. Okay, and again y2 minus y1 will give me delta y2. Then yn minus yn minus 1 will give me delta yn. Now this is how we have constructed our backward table. I will show you an example, then you will understand how they have constructed. Okay, now we are going to see what is this E. This is called the shifting operator. What is this? It is called the shifting operator. That is how much distance we are displacing, or it is called also as displacement operator. That is how much is the difference. Okay, how much we are displacing. So E of f of x naught, that is the first difference, will be equal to f of x naught plus h. This is a very important formula which will be required in the exercise problems. So E of f of x naught is equal to, that is the shifting operator of a given function, will be f of x naught plus h, where h is the equal intervals, where h will be the equal intervals. Now again we have the properties for our shifting operator. Again, that is, we can split the functions according to the splitting operator, and again there's a constant. I can remove the constant to the outside, and then I can use the formula. Then the relations between the forward operator, backward operator and the shifting operator. These three is very, very important. Delta is equal to E minus 1. Delta is equal to E minus 1. Then E into delta is equal to delta into E. This is also another important formula. Now, and the third one will be that your backward operator is equal to E minus 1 by E. E minus 1 by E. You have to write these three properties also in your notebook, because anytime this can be asked in your 1 mark. Okay. Now you are going to construct the forward distance difference table. How we are see? I'll show you this example. Then we will move forward to our exercise. Now they have given x and y. They have given 4 values each for x and y. Now I'll form the table such that x and y are in the standing position, that is in the vertical position. Now I put 0, 10, 20, 30. I have left some space between. Okay. Now I place y 0, 0.174, 0.347, 0.518. Now I subtract 0.174 minus 0, I get 0.174. 0.347 minus 0.174, it's 0.0173. Similarly, I will be finding, when I am finding the difference here, it is 0.173 minus 0.174, that is why I get the minus here. Similarly, I will get subtracting here also, I will be getting a minus sign. And then I will subtract between these two. You have to take the second one, that is minus 0.002. Minus of minus will become plus. So I will be getting whatever the value, I will be having it here. Now I can, they are just asked to just construct the forward difference table. So constructing the forward difference table should not be a problem. So we will be going to the exercise directly now. Now we are going to the exercise. Exercise 5.1. First one, it says delta log of AX. Okay, delta into log of AX. You have to find the evaluate, that is evaluate delta log AX. Now we know the formula. What is for delta f of x? Delta f of x is equal to f of x plus h minus f of x. Now I am going to apply the same here. So what will happen? My delta log AX will be replaced by, what is the function? Log. Now I can replace x by AX. So this will become AX plus h minus log of AX. Now using the log properties, I can say log of AX plus h divided by AX. Now if I take the or I can take simplified version, that will become log of 1 plus h by AX. Yes. Now moving to the second one, you can write this as we know that. Okay. Moving to the second one, you have to construct the forward differences table. You have been given y is equal to x cube minus x squared plus x minus 1, where x is equal to 0, 1, 2, 3, 4, 5. Okay, you have to construct the forward differences table. Now when I can say I'll form two columns x, y as of now. Now when x is equal to 0, my y will become, when x is equal to 0, my y is equal to minus 1. Now when x is equal to 1, what will be my y? It will be equal to 0. Okay. Then I am giving enough space. You also should give enough space between the values. Now when I put x is equal to 2, I substitute here and I will be getting y as 5. Now then when x is equal to 3, I get y as 20. When x is equal to 4, I get y as 51. When x is equal to 5, I get y as 104. Now what will be my delta y? Then my delta square y. As of now you keep it. Then if we get values for delta square after that, then we will put whatever the column names. Okay. Now 0 minus of minus 1. So I will be getting plus 1. See where I am writing this plus 1. Between 0 and this minus 1 I am going to write 5 minus 0, I will get 5. 20 minus 5, I get 15. 51 minus 20, I will be getting as 31. 104 minus 51, I will be getting 53. Now I subtract this. 5 minus 1, I will be getting 4. See where I am writing this 4? Between 5 and 1, I will write this 4. Now 15 minus 5, I will be getting 10. 31 minus 15, I will be getting 16. 53 minus 16, I will be getting 13, I will be getting 22. Now again, I can subtract here. I will write delta cubed y. 10 minus 4, I will be getting 6. See, between 10 and 4, I will be getting 6. 16 minus 10, again I will be getting 6. And 22 minus 16, I will be getting 6. Now I have delta power 4 into y. 6 minus 6, 0. 6 minus 6, 0. Then again there is another. So this is your forward construction table or the table with forward differences. Now what I did, I just substituted the values of x in this polynomial and I found out the values of y. Then I started subtracting one by one and I started placing in between those. Okay, now coming to the third problem. When h is equal to 1, you have to prove E inverse of delta. That is E inverse into delta, okay, into x cube is equal to 3x squared minus 3x plus 1. Okay, now here we are going to use this formula. What is this? We know E. Now we are going to find what is E minus 1, that is E power 1. That is E power minus n or minus 1 into f of x is equal to f of x minus nh. This is the formula which we are going to use in this problem. Now I can write E minus 1, okay, into delta of x cubed as E minus 1 into delta x cube. That is, I have replaced I shifted the brackets. Now, what is delta x cube? What is delta x cube? That is what is this? Delta x. Delta x we know it is x plus h minus x naught. Is it not? So now I am going to use that. So this will become x plus h minus x naught. So what is x h here? X plus h the whole cube minus x cube. Now I split this. I can write like this. Is it not? I can split E minus using my distributive property. Now I apply that for here alone. E minus f of x. E minus 1 of f of x is equal to f of x minus nh, or I can say this is n. Okay, now nh. Put the 3 inside. Okay, now I am going to use it for each of this the same formula. So E minus x minus nh. So x plus h minus h the whole cube. Okay, so what is this? First portion, that will be x plus h minus nh. So there is one h here, the whole cube, minus, coming here I will get, instead of x plus h I will only have x, and then there is one h here. So this is this h and this gets cancelled as x cubed minus x minus h the whole cube, which is equal to x cube minus x cube, I can say minus 3x squared h plus 3xh squared minus h cube. I am expanding using a minus b the whole cube. Now what will happen when I substitute h is equal to 1, because they have given, it will become, I am taking this minus inside. This x cube will cancel. You will get 3x squared minus 3x plus 1, which is equal to our, which they have asked, your right hand side. Okay, so what I have done is, I have used this formula as main formula. E power minus n is equal to f of x, which is equal to f of x minus nh. Then I have used this inverse operator, inverse shifting operator, or you can say your shifting operator alone with your power minus 1. Then I applied the formulas. I split that into 2. Then I used the formula and I got it. Okay. Now I am going to move to the fourth problem. Okay. What is the fourth problem? Fourth problem is f of x is equal to x squared plus 3x. Now we have to show f delta into f of x is equal to 2x plus 4. Okay. Now we know what is the formula for delta f of x. Delta f of x is equal to f of x plus h minus f of x. So here what is my f of x plus h here? My f of x is x squared plus 3x. Okay. Now I am going to use that. How will I use? Instead of x, I am going to use x plus, I will be using this x plus h in this place. So x plus h the whole square plus 3 into x plus h minus x squared plus 3x. Okay. Now what will happen? This is nothing but I will expand and I will remove the bracket. I will remove all in one go so that I can cancel it easily. This 3x and this 3x will get cancelled. I will be having only this 3 values, that is my h squared plus 2xh plus 3h. Now if I put h is equal to 1, when I put h is equal to 1, what will my delta f of x will become? 1 plus 2x plus 3, which is equal to 2x plus 4. I add this, so I am getting my right hand side, or hence proved I can say. Okay, I just applied the formula, I expanded, and then what I am doing is I am finally simplifying with h is equal to 1. Now moving to the fifth problem. Fifth problem, you have an example, similar example, which is example number 5.5. You can refer example 5.5 because we are going to split this as our partial fraction and then we will be proceeding. Okay, we will proceed in the next class. So as of now you have to understand what is delta, what is the shifting operator, what is the backward difference table, forward difference table, and how we are going to apply in our problems. Okay, thank you.